In this lesson, we continue with differential calculus, but this time we are going to use differentiation to find the equation of the normal and also the equation of the tangent given a point of contact. So we can represent graphically. Let's see what it means by the normal and the tangent. Let's say we have xy plane. And let's draw, we have a curve like this one, so this is our curve. Okay, now what I'm going to do, I'm going to draw a tangent in green. So this line in green is a tangent because it touches the curve at one point only. And we are going to use the letters A, B, C to denote our tangent. So say line ABC is a tangent. And remember, tangent is a line that touches the curve at one point. Then also we are going to draw a line of the normal. Now, when drawing the line of the normal, the line should be perpendicular to the tangent. It should be perpendicular to the tangent. So, what we are saying is if we have this line, and we'll say line BD is a normal. Because here we are going to have an angle of 90 degrees, here we are going to have an angle of 90 degrees. So therefore, we can say a normal line is a line that is perpendicular to the tangent at a point of contact. Also, the other point we need to know, the point where the three lines are meeting, this point is known as point of contact. And the point of contact is given in form of coordinates. So we have x, y. Sometimes you may be asked to find the point of contact. Now, in order to find the equation of the tangent and the equation of the normal, we'll use the equation of the straight line. Y minus y1 is equal to gradient, open brackets, x minus x1. So this is the formula that we should use for us to find the equation of the tangent as well as the equation of the normal. Now, for this formula to work, we need to have a point. So we need x, y. So we need a pair of coordinates like this one. So now, the coordinates that we use in order to plug in where there is y1 and x1 from the formula, this one is the point of contact. So the point of contact is a pair of coordinates that we use in order to find the equation of the tangent and the normal. From there, we can see that we need to also have the gradient. Now, gradient can be found by differentiating the equation of the curve and plug in where there is x with the given x. We'll see how it goes with the examples later. Now from there is another note that we need to have. Like if I have the tangent, not the tangent, let's say if I have the gradient of the curve, if we are able to find the gradient of the curve, we have to know that the gradient of the curve is equal to the gradient of the tangent at a point of contact. Then, what of the gradient of the normal? The gradient of the normal given the gradient of the curve can be found by gradient 1. So say gradient 1 is the gradient of the curve times gradient 2, the gradient of the normal, must be equal to -1. So these are initials that we have to know if we are dealing with equation of the tangent and equation of the normal. Let's look at some examples. So this is our first example here. We have been given equation for the curve y is equal to x squared minus 3x minus 4. So this is a quadratic equation here. Now the question is find the equation of the tangent. We said the equation of the tangent can be found by using the formula y minus y1 equals gradient open brackets x minus x1. So as we can see, we need a point. Now from the point we can see that we have been given the x coordinate. The x coordinate is -2. So now before we proceed with our equation of the tangent, first we need to find the y coordinate. Then after finding the y coordinate, we need also to find the gradient. Okay, so now let's now go back to our equation. We are going to find the y coordinate. So when finding the y coordinates, you plug in the value of x. So the value of x is known in -2. So where there is x, we put -2 squared minus 3, -2 minus 4. Y is equal to, here we have -2 squared, -2 times -2, we have +4. Then here we can see that we have two negative signs. We have 3, so 3 times 2, we get +6 minus 4. So we can say that 4 minus 4, 0. So our answer here, we have 6. So the y coordinate is +6. Now after finding the y coordinate, we can now proceed to find the gradient. So finding the gradient, we are going to differentiate the equation of the curve. So the equation of the curve is x squared minus 3x minus 4. Now to differentiate this one, we'll say dy over dx. So we need to differentiate x raised to the power 2. We are going to use the power law. If we have x raised to the power 3, its derivative is 3x raised to the power 2. If we say x raised to the power 5, the derivative is 5x to the power 4. If we have maybe 5x, the derivative of 5x is just 5. So after bringing the power to the front, we need to subtract 1 from the power, that is the power. So this is what we are going to do also with the first part here. So we are going to bring the 2 to the front. We have 2x, then we subtract 2 minus 1 minus 3. Here we said if you want to show the working, you can just indicate the 1, then we bring down our 1 x, so 1 minus 1 here, then the derivative of a constant number is 0. So we can proceed. We have a 2x raised to the power 1 minus 3, x raised to the power 1 minus 1, we are going to get x raised to the power 0. And always x raised to the power 0 is 1. So we have 2x minus 3, where there is x raised to the power 0, we just substitute with 1. So 2x minus 3. This is now our dy over dx of our curve. Now, where there is dy over dx, we can put the symbol gradient. So gradient is 2x minus 3. So after we have found first the derivative of the equation of the curve, we can plug in where there is x with the coordinate from the point of contact. So we have -2 minus 3. So we can see that we are going to have gradient is equal to 2 times -2. We get -4 minus 3. gradient is equal to negative 7. Okay, so this negative 7, remember this is the gradient of the curve at the point of contact at negative 2,6. So the gradient of the curve is negative 7. We are going to use now the principle that states that the gradient of the curve must be equal to the gradient of the tangent at the point of contact. So the gradient of the tangent here will be negative 7. So now we can proceed with this equation. So we'll say y minus y1, we have 6. The gradient is negative 7, x minus negative 2. So y minus 6, negative 7 times x, negative 7x. Then here, negative times negative, plus times negative, we still have negative 14. Then this will be shifted to the other side. We have y is equal to negative 7x minus 14 plus 6. So y is equal to negative 7x minus, we are going to subtract because of the different signs, 8. So this is now the equation of the tangent at negative 2,6. Okay, so now we move on to example 2. Determine the equation of the normal to the curve y is equal to 2x squared minus 3x minus 2 that passes through 3,7. So the equation of the normal can be calculated by the formula y minus y1 equals gradient open brackets x minus x1. So as we can see, we need the tangent. Now this time, we need the gradient. This time we are looking for the gradient of the normal. Then we need a pair of coordinates, but this time we have been given the x and the y, so no need of finding the y coordinate this time. So our pair of coordinates is 3,7. Okay, so now let's begin by differentiating the equation. So y is equal to 2x squared minus 3x minus 2. So we can say dy divided by dx. So we bring the 2 to the front. We have 2x, 2 minus 1, 1 minus 3. We said where there is x raised to the power, its derivative is just 1. Then the derivative of a constant is 0. dy over dx is equal to 2 times 2. We get 4x minus 3 times 1, 3 minus 0. So where there is dy over dx, we substitute with m. 4. Now we need to plug in the value of x from the point of contact. So from the point of contact, the value of x is 3 minus 3. So the gradient is equal to 4 times 3, 12 minus 3. 12 minus 3 is 9. Now remember, this 9 is the gradient of the curve and also the gradient of the tangent at the point of contact, but we are looking for the gradient of the normal. So if you have the gradient of the curve or the tangent and you are trying to find the gradient of the normal, if you have a whole number like 9, so what we are going to do is gradient of the normal will be equal to 1 over 9, but it will have a negative sign. So if you have a number like 9, a whole number 6, 7, you make it a fraction, 1 over that number. If you have a fraction, you just interchange the numbers. Like if we have 2 over 3, if this is the gradient of the tangent and the curve, the gradient of the normal will be 3 over 2. Then you change the sign. So meaning if the gradient of the tangent and the curve is positive, the gradient of the normal must be negative. Okay, so we have negative 1 over 9. So we can now proceed y minus our y1 from this we have 7 gradient negative 1 over 9, then x1 is 3. So we can simplify, but let's multiply everything by 9 so that we get rid of the fraction. So this 9 will multiply with y, number 2 it will multiply with this, and it will also multiply with the negative 1 over 9. So we can say 9 times y, we get 9y. 9 times 7, we get 63. Then 9 times this, so this 9 here will cancel with this one, giving us negative 1 x minus 3. So the reason why I multiplied by 9, I just wanted to get rid of the fraction so that we reduce over in terms of time consuming. So we can proceed. We have 9y minus 63, then negative 1 times x we get negative x, then negative 1 times negative 3 we have positive 3. Then this will shift to the other side. We get 9y is equal to negative x plus 3 plus 63. So the sign will change from negative to positive. 9y is equal to negative x plus 63 plus 3, we get 66. So we can leave our answer here, or if what we can divide everything by 9, but we can just leave our answer here. So this is the equation of the normal. Okay, let's move on to example 3. The equation of the curve is y is equal to x raised to the power 3 minus 3 over 2 x raised to the power 2. Find the equation of the normal where x is equal to 2. Okay, so the formula for the equation of the normal, y is equal to y minus y1 gradient times x minus x1. So we need the number one, the gradient of the normal. Then also we need the coordinates for the point of contact. Now for the coordinates of the point of contact, the x coordinate is given, so there is a need of finding the y coordinate. So we begin by finding the y coordinate. So let's write our equation for the curve. Y is equal to x to the third minus 3 over 2 x squared. So we'll substitute where there is x with 2. So 2 raised to the power 3 minus 3 over 2. Here 2 times, I'll just say 2 times 2 since we have x raised to the power 2. Now 2 raised to the power 3 is 2 times 2 times 2, 3 times. So 2 times 2, 4 times 2, we get 8. So 2 raised to the power 3 is 8. Minus, we can cancel 1, 2 from there. Then 3 times 2, we get 6. Y is equal to 8 minus 6 is 2. Okay, after finding the y coordinate, let's now find the gradient of the curve by differentiating our equation. So we can have y is equal to x to the power 3 minus 3 over 2 x squared. So what do you think is the derivative for x raised to the power 3? So we can see dy over dx is equal to, we bring the exponent to the front, we get 3x raised to the power 2. We said as soon as the exponent is written down, or in front of x, the power reduced by 1 unit, minus 3 over 2. Then we will bring our 2 to the front. We have 2x raised to the power 1. So we can see that we can simplify our negative 3 over 2 times 2x. That one will be, if we want, we can just say 3 times 2, 6, divided by 2, 3. Or we can just cancel the 2. Then negative 3 times x, we get negative 3x. Then from there, where there is dy over dx, we put the symbol for gradient. 3 now. Let's find the gradient by plugging the value of x from the point of contact. So the value of x from the point of contact is 2. So 2 squared minus 3, 2. Gradient is equal to 2 squared, 2 times 2, 4 times 3, 12 minus 3 times 2, 6. Therefore, the gradient of the curve is equal to 12 minus 6 is 6. Now remember, in order to find the gradient of the normal now will be 1 over 6, since we have been given a number, and negative 1 over 6. So we can proceed here. We can say y minus y1, our y1 is 2. Then our gradient here is negative 1 over 6, x minus x1. So I'll do the same. I'll multiply by, this time by 6. So 6 times y, we have 6y, minus 6 times 2, we get 12. Then 6 times the expression on the right side, the 6 will cancel, leaving us negative 1, x minus 2. 6y minus 12, let's expand by multiplying everything in with negative 1. So negative 1 times x, negative x plus 2. So 6y. Now this negative 12 will shift to the other side. We are going to get negative x plus 2 plus 12. So 6y is equal to negative x plus 2 plus 12 is 14. So we can leave our answer like this, or if we want, we can just say 6y is equal to negative x plus 14. We can divide here by 6, here by 6, also there by 6, so that we have y is equal to negative 1 over 6x plus we can reduce 2 into 14 is 7, 2 into 6 is 3. So we can leave our answer here, or our answer there. So that's it for this video. Thanks for watching.